Um, welcome to this mentoring workshop, and this is a unique workshop in the context of following a sort of a mentor-mentee type of relationship that we're going to establish the next 2 days. We have incredibly distinguished speakers from arts, humanities, science, and engineering. And I think to hear them in one place, I think we are all blessed because of this, their distinguishedness and so on and so forth. Before we start, I want to really acknowledge Professor and Dr. Baldev Raj, who is the director of the NIAS, who is instrumental in many ways in having this entire NIAS MAIYA's PRODIGY program. And then, of course, Professor Ramarao from National College, and then Dr. Anita Kurup, also the dean and the professor at NIAS. And I think I'm Ram Iyengar. I'm the director of the School of Computing Science at Florida International University. I'm also an adjunct faculty at NIAS. Thanks for Dr. Baldev Raj for giving me an opportunity on this. So at this point, I think we want to show a small movie which is about 4 minutes. With the blessings of Professor C.N. Rao and others, we launched this program. And so you will see a few of the things what we did, and then a follow-up of this workshop on this. So can we show this movie? And after that, what we want to do is we want to light the candle, and I'm also waiting for Professor Kasturi Rangan. If he can make it, then he can also be a part of lighting the candle. So in any event, we'll start. And with this movie, that will take maybe 4 or 5 minutes, just to sort of give you an overview and an introduction of how we launched this program and how successful it has been. Again, I want to thank, and it will sort of give you an overview of what we have gone through in this program.
Those 10 whom we selected, after having done the studies in NIAS, as to what is giftedness, how the gifted children manifest themselves, how giftedness in a culture and in the habitats when you move from villages, districts, to cities, to the metropolis, how do they perform, and how a gifted children has a rainbow manifestations as they go along in their life. They are never in one mood. So it was with that experience that Professor S.S. Iyengar, myself, Professor Ramarao, and Professor Anita Kurup interacted with the select students who had come through the matrix which we have evolved in the specific context of India.
My duty is to tell something about this system where we are encouraging. The first thing is, tennis is a very important game in Australia, They say catch them young. The same philosophy comes here. Catch them young to get better scientists,
It's indeed a very happy occasion, particularly for this set of students who are getting a significant recognition for their talent. Making sure each of these people have an opportunity to make use of their gift and talent which they have and nurture it and make sure that it results in a tangible output, not only for our country, but also for the entire humanity, is a tremendous task and a great job.
When I said, Professor C.N. Rao, you should come, and there are a lot of people here, in my dream, you'll be one of those C.N. Raos in years to come. And that's my real dream, and that's very important for us.
Now, if I'm correct, I think the main thing actually why I have selected this, jumped on to the program, just for one reason, that 1%, the entire 1% should get the Nobel Prize.
I cannot tell you how overwhelmed we are over this function. I think there could be no other better beginning for the mentoring program with Professor C.N. Rao's talk.
However great you become as a scientist, however great you become as a thinker, don't forget that you're a human being. You have to have simple life, you have to have simplicity, and ordinary, deal with ordinary people like we should. Simplicity is very important. But not only simplicity, behaving well with fellow men.
If you have an idea, if you have a dream, and if you know you want to accomplish it, this program will definitely help you.
MAIYA Prodigy program is a program to attract talents among young high school students. It's a program something very similar to Intel Talent Search Program or Google's Talent Search Program. Well, the MAIYA Prodigy program is a program for mentoring to attain intellectual youth achievement in mathematics, applied science, technology, engineering, and research. Essentially, you can sort of encapsulate that as master for great minds. In many of the other programs that you see on the Talent Search program, the focus has been on science, engineering, and mathematics, but here we are also interested in exploring and sort of extracting talents in the context of arts and humanities, among the high school students.
As we got to know that this is one of the most uniquest programs I've ever seen. Here, unlike those other fellowship programs wherein students are judged based upon their merit or how much they score in a particular exam, new ideas, our talents were encouraged, which is not usually seen in any other programs.
My advice to you is to literally just be yourself, because that's exactly what they want from you.
Okay, I think that should be the end of it. Now it's my great honor to introduce the most important person who sort of orchestrated the whole idea of the NIAS mentoring program is Dr. Baldev Raj, and he's the director of the NIAS program, and he is one of the giants like other distinguished scientists, a material science specialization, director at Indira Gandhi Atomic Research Center for Excellence, and also a Padma Shri and hundreds of papers. So let us welcome Dr. Baldev Raj to say a few words at this time.
Good morning, young boys and girls who have been selected for the NIAS MAIYA Prodigy Fellowship, other young students, the mentors, the parents, the invitees, and everyone who is in this hall. We are very fortunate that we have you. How can a family rejoice without children? We are all on the outer ring of you. You are at the center. This whole program is for you. You became the part of this family when we inducted you on January 6, 2017. As Professor S.S. Iyengar told you, we are blessed with the presence of Professor C.N.R. Rao, an icon in science, not only in this country, all over the world, and known for his human values, doing science, working for the country and the world in many ways. Today, when you come here, you have the possibility of listening and interacting with a colossal person who has abridged science, technology, not only on this planet, but with the cosmos. He is a man who built space. Many of the achievements which you see today are possible because of the contributions of Dr. K. Kasturirangan, but he would not mention any time. I have listened to him. He would always mention his mentor, Professor Satish Dhawan and Sarabhai, and be very humble to say that I have made the contributions. But those who know him really know that what he did, what he continues to do, and how large his contributions are there. We are very fortunate, sir. Today you are amidst us. And more important, the young girls and boys, the other mentors, and the parents would listen to you. We are thankful to Professor S.S. Iyengar, who has become an inspiration for all of us to carry forward this program. His commitment is so large that we sometimes think that whether he is doing something else or he is doing only NIAS MAIYA PRODIGY program. He keeps on reminding us, and he really has envisioned it. And it was his idea that he said that so much has been done and written about the mentors and the mentorees, that when we start these young girls and boys on this journey, they must know what is the mindset of a mentoree, how do they look at their own aspirations, how do they interact with the mentor. And it is not very easy to be either a mentor or a mentoree. There are not many great examples where the people have been able to do the mentor and mentoree to realize the aspirations. Every human being has infinite possibilities. Some realize that and some don't realize in their life. But there is no doubt that in the hands of a proper mentor, you can realize all those possibilities. We are fortunate here that Professor A.H. Ramarao, you all know he is the president of the National College, a great educationist, and arguably would have mentored many more young children as compared to any of us. He is a part of our program. Professor Anita Krupp, who is the head of the education program and a dean, is the anchor for us, and who is your contact point also to be able to do that. We are just fortunate. Professor P. Balram has just walked in. You know him. He was the former director of ISC and a great biologist. What do I wish to mention to you is not much. First of all, welcome to NIAS. NIAS is your nest as you grow up. So nest is very dear to the bird. So you please fall in love with NIAS. That would help us and that would help you. So that is my first request to you. Second request is that I want to quote to you relation of Sachin Tendulkar and Ramakant Achrekar. There is no doubt that Sachin Tendulkar is a gifted person. Absolutely no doubt. Some called him genius also, but definitely he is a very gifted person. If you study the relation between Ramanath Achrekar and Sachin Tendulkar, he always called him Achrekar sir. And he also recalls that how affectionate and how strict Ramanath Achrekar was with him. So when you have a relation of a mentor and mentoree, it is not always affection, it is not always love, it is not always encouragement. It would be also demanding from you certain actions which are in interest of you. At that time, you may not like it. You may feel that why I am being stretched. Or I want to do the work and the mentor is saying, no, you relax. We do it later. So you have to have a relation which is very unique between a mentor and mentoree. So this whole workshop is that you would experience some mentors, they would experience your presence, and we hope that you would find a proper person with whom you can spend time to realize your aspirations, and mentor would find satisfaction in mentoring you. So that's the whole idea. We are going to spend most of the time like you. Even people like, I gave you example of Sachin Tendulkar and Ramanath Achrekar. I'd also give you the example of Mohandas Karamchand Gandhi. he also acknowledges, one would have imagined that the kind of a person that Mohandas Karamchand Gandhi would not have required a mentor. But he also required a mentor. Gopal Krishna Gokhale, he acknowledges very clearly that Gopal Krishna Gokhale was his mentor. He came to South Africa, and after that, Mohandas Karamchand Gandhi was no longer the same Gandhi, but he was who went to South Africa to pursue law. Any one of the persons who have achieved significantly in life did discover a mentor. So when Dr. S.S. Iyengar was mentioning to you that this is a unique program, there are many mechanisms and organizations who search for talent. They support them with large money. They support them in any possible way, encourage. But this working together, possibly for a lifetime, is a very, very rare opportunity. That means here you and the mentor has to commit, and the NIAS, MAIYA with the Iyengar Foundation and National College, we are committed to enable you. We don't know what you would need as you go along in your journey. So we have to be dependent on you to tell the mentor in a very honest way that what you need. If you don't mention that, then I think our journey is not going to be that very joyous. At the same time, be very clear that you are going to have a lot of fun. You are a child who is walking into adulthood. It's a period which is very rare in the life. So if you don't have fun, if you don't have all the creative moods and tantrums, then I think we have taken away something from you. So you would keep all that and still pursue what is your aspirations. You would hear from Professor S.S. Iyengar about the foundation and their commitment. Also, Dr. MAIYA, you heard his commitment to the gifted program, and of course Professor A.H. Ramarao with respect to what National College do to the young children, and they have brought out outstanding people out of their education system. And Professor Anita Krupp would tell you about what education program in NIAS is. Why particularly NIAS as a nest for the gifted children? Because this is, to my mind, the only interdisciplinary institute which combines philosophy, mathematics, science, technology, arts. In fact, we have no boundaries with respect to discipline. To put them together in a very little space but with a big challenge to solve the problems. There are big universities where all these disciplines are there, but they all pursue. When I even interact with University of Cambridge or Stanford, they say, yes, we have all these disciplines. But the way NIAS works, we don't work like that, because you are in a very little space, beautiful space, and you almost for everything interact with everybody to be able to find it. I thought it is very good for young people, because the world which you are walking in, there are no boundaries of discipline. You may be scientists, you may be mathematicians, you may be artists, but I think you have to combine everything to realize what you are doing. So that is why we believe NIAS is a nest for you. I can go on. This is something area which I would have liked to speak, but Anita would give me only 10 minutes. So I would restrict myself to 10 minutes, but I would be available. I would be many a times in this room and have the opportunity to speak to particularly our prodigies, and also with the parents and whosoever feel that they can commit to this program. Please use this 2 days to discover yourself, and also allow you to be free to talk to as many people as possible. In the end, you would be requested to express yourself that right from the time when you came into this fold of NIAS MAIYA Prodigy Fellowship, what has been your journey like? Are you satisfied with your journey, what you are doing? Would you like more from this fellowship to be achieved, and how we can work together? We all have realized that when we really look at any country and say who are the people who have really contributed, you cannot count many people. There are always 10 and 15 people which come naturally to your mind, and after that you don't know who are the people. But it's a fact that millions of people, very gifted people, some who came to light and some who are not even visible today, they have contributed. So your journey, we are not envisaging where you would get a big designation, you would get big award, they would come. Even if they don't come, still your gift can be shining all the time wherever you are working. So our concept of the gifted is to allow you to discover yourself in this unique journey by virtue of your birth on this planet. So I wish you very well. We have wonderful speakers, each speaker endowed with a large experience, his own experience, her own experience, who is going to tell. It's going to start with Dr. Kasturi Rangan, Professor P. Balram, it goes on, and then each one would tell you stories, would tell you their experiences, would tell you how they have negotiated with all the things, and I believe they would become your friends. I don't want to use the word network, I still use the word classic words like friendship, sort of your companions in your journey. So thank you very much, and it's a great honor today to be present here and welcoming you to NIAS.
Let me invite Professor P. Balram, formerly the Director of Indian Institute of Science, to just say a few words in this inauguration thing. We will call you back for your session, Professor Balram.
Thank you, Anita. I won't say very much at all. I will talk again after Dr. Kasturi Rangan. So I must say that it's a pleasure to be here. And I must also confess that I don't know very much about the program. I don't know what all of you would like to hear, but I hope that as the day proceeds, some of it will make sense. Thank you.
Let me now invite Dr. Ramarao to say a few words.
Good morning. On one hand, we have got very, very distinguished scientists, Dr. K. Kasturi Rangan, Dr. Balram, Dr. Baldev Raj, Dr. Iyengar, Dr. Anita. On the other hand, we have got very, very distinguished budding scientists, those nine members who have come here, and their parents and other people. Maybe few years back, 2 or 3 years back, I was discussing with Dr. Iyengar about the Westinghouse model of Intel, That's an important one, known throughout America, Westinghouse model of Intel. The whole importance is like this. If you take 100 Nobel laureates in America, you can count there, but that has no sense in India. You can't count more than 3, 4, There you can count 100 Nobel laureates in those campuses, Stanford or Berkeley. 80% of them, when they were like you, when they were young, 16 or 17, were the scholars of the Westinghouse. That I discussed with Sitaram Iyengar, how to start one. Then he told me, let us discuss with NIAS also. They were thinking about some prodigy program. And then our Sada and MAIYA, my students, and all of us joined and started this, what is called as NIAS MAIYA Prodigy program. To support youngsters, my idea was in science, but in different fields also. See, in fact, Dr. Kasturi Rangan reminded me about our own college just now. We have got the Bangalore Science Forum, which was started in 1962. And every year, we conduct a science festival, July 1st to July 31st. Date is fixed, but not the year. And Dr. Kasturi Rangan has given more than 10 to 11 lectures there. Balram, you won't miss him at all, Every year, we'll ask him to give a lecture. Like that, Dr. Padmanabhan and other people. But this year, for your information, I'm telling you, I got one student by name Ravi Narayan, who is the head of global delivery at Microsoft Seattle. He came to my room about 3 days back. When I told him, he told me he has gone to America again. He will come back by America in the month of July, give a talk on 28th July on how to start startups through innovative technology in India. That is 28th July, 6 p.m. For all the 10 people, this is important. Please attend that one. Then today, when I wanted to speak here, world-changing ideas. There are 10 world-changing ideas. Not that I'm going to take all of them. The first one, they say, giving data collectors and donors a real-time rush. The second one is correcting the vision from the cloud. There is some relationship here, for that and also for India. There's what is called connecting eyes. This is an important thing for you. There are around 55 million visually impaired people in India. 55 million. Up to 80% of whom could be helped by everyday procedures like LASIK. Medical and surgical resources are, however, limited. In April 2015, such a new thing, 2 years back, non-profit LV Prasad Eye Institute in Hyderabad, India, teamed up with Microsoft India to create Connected Eyes, a cloud-based machine learning research project that uses data from tens of thousands of eye patients to identify the likelihood of success of new surgery plus a probable regression rate so that doctors can deploy those sources most effectively. Last December, very recently, Connected Eyes linked up with institutions in Brazil, Australia, and the United States to create the Microsoft Intelligent Network, note the word Intelligent Network, for eye care, which will build a universally available service that offers eye doctors immediate predictions for their patients. This will be a global pool of knowledge that everyone can benefit from. This is entirely segmented to the 9 people. One of them was asking Dr. Sitaram Iyengar about this the other day when he came out the Connected Eyes. Then we have got what is called rethinking about the factory, taking back a block, respecting marine life, keeping tabs on little ones. They're all what's called world-changing ideas. Luring carnivores to go vegetarian, maximizing space and returns, studying the wind, that's such an important thing. One can give 2 hours of lecture on that, studying the wind. Helping students shoot and learn. That one I have given you a little bit about it because that's important for you. So many people are here, particularly in America, they're weak in mathematics. What they taught, NBA maths hoops, that's called. When 8th graders, observe this is not a big problem, 8th graders play the NBA math hoops game, they get to assume the role of basketball coaches. That you will become a coach, you are not a student. Using real players' actual statistics to make decisions about whether a player should take a 2-point shot or a corner three, that's for basketball. As the kids soon discover, they are applying math skills they might otherwise have considered boring. Generally, there people think maths is boring, We have a vision for every student to fall in love with every subject through things they already care about, says Khalil Fuller, CEO of Learn Fresh. That system is Learn Fresh, the non-profit that first created a physical edition of an app version. Fuller, who watched friends drop out of high school after they fell behind in maths, was inspired to develop the game after a college instructor introduced the idea. He has since formed a licensing deal with the NBA to use stats from real players to make the game extra arithmetic. The students idealize these players. Fuller says, it's kind of like your idol is coming to teach you maths. Right now, 20,000 students in 35 cities play the game. The new app will target millions. And for the kids who are not interested in basketball, you can take the football. But Dr. Baldev immediately brought Sachin Tendulkar name, India, the blood is cricket. You know Dhoni, you know Tendulkar. You become one like that and learn mathematics and physics, everything. This you can go on internet and see, Learn Fresh Education, how they do it. And exactly meant for those students who feel science and maths are boring. That is played through cricket, With this, today, I wish all of you for a comfortable stay here and interactive sessions and an intelligent way of thinking, and pick up something and tell us that what you want next year. Let us not repeat it. Thank you.
Well, again, I want to sort of give my own experiences for all of these students who are here. I don't want to take too much of time, but just give a couple of nice, interesting experiences I had during my stay in United States for over 45 years. So one of the things which I found very interesting early on in my doing PhD program, my advisor came and I asked him, what problem do you want me to solve? Then he said, I'm talking in early 70s, we didn't have internet and all of those facilities. And he said, well, I'm not going to define a problem for you. I would like you to define yourself. I just graduated from Indian Institute of Science at that time and then went. And of course, the training I had was certainly helpful. So what is the thing which sort of facilitated me is, I thought to start with, how do I define a problem? So then I thought, whatever we think impossible becomes really inevitable, which is very important. So, in the next several years, we did define a problem, did very well. Then I went to, Carnegie Mellon and other places where I spent some time at national labs. So that is one of the experiences. So when he said defining a problem, so the burden is on me. So it took quite a bit of time to understand how serious the advisor was. So it is very important that during the process of these 2 days, we are able to sort of translate the idea. If somebody feels, my God, it is too impossible for me to do it, I don't think so. It is certainly possible, provided we have a passion and certainly some real goals to achieve that. So that's one interesting thing. The next experience I would like to share that I was working on what I called as a deep learning and machine learning systems. I was a visiting faculty at Jet Propulsion Laboratory in Caltech. So there was a very, very famous professor who is actually a professor of aeronautics by name Hans Liebmann. So I went and then I said, he said, where are you from? I said, I originally, from Indian Institute of Science. Oh my God, you must know Professor Satish Dhawan. Of course, I said, he was the director when I was a student here. And then he also said, you should know Professor Rodam Narasimha. Apparently, I found out both of them were students of Hans Liebmann. But I think what is very interesting is, whatever Professor Dhawan learned from Caltech, when we were students, I'm talking in late 68s, when we joined the first year of ME program, the tradition in those days used to bring all the students of the institute to have a cup of tea with Professor Dhawan. And he was so curious to talk to each one of us and say, okay, Mr. Iyengar, tell me you want to work, what do you want to work, where do you want to work, that kind of a conversation. And then finally he said, what is very important is how you translate your idea to real-time application. Because I found out later on, he was an experimentalist, which he did very well, at Caltech. So it's very important, the thing that we are going to sort of discuss, and you hear from all of our distinguished speakers, how can we sort of translate any idea, it may be in music, arts and passion, anything, what is the kind of an end result that you are looking, which will have an impact on all the people. So that's the second lesson. The third story, I have lots of stories to say that, but this third one is more important, is also because Oak Ridge National Laboratory is a very prestigious lab. I was a visiting professor. So one summer like this, around May 25th, I go there. The director of the lab comes and says, Ram, I want you to do something before you leave the end of summer to your university. And he did not tell me what it is. And then he said, you come and see me in my office. So then he said, I would like you to design an intelligent robot, to detect radiation leak. In those days, Oak Ridge National Lab was very much interested in designing robots to sort of detect, radiation leak in the laboratory. So one of the big projects the Department of Energy sponsored is to identify a real intelligent robot. I never heard about it. And, I was a theoretician to start with. Then I said, Chuck, I don't know. I'm a theoretician, not just a person who can build system. No, I will provide all the help that whatever you need, but I would like to see something going. So again, this illustrated, that was an impossible task at the time when we said, but by the end of summer, we had developed a beautiful system. He was so fond of it. And then he said, I would like you to come and I will pay a lot of dollars, millions of dollars for your research project, go back to your university. So the moral of this real beautiful story, is although at times I thought, my God, these are some of the impossible things that how can I do that? And, it became inevitable and we were able to do a lot of good things. Well, I think in the next 2 days, and you'll hear to all of the distinguished speakers, they will talk about their experiences and so on. We will learn a lot from them, and we'll challenge you, and you should be asking questions. That's one of the things we would like to do is make it more interactive. And, my own vision is to see with all of our distinguished guests to build, a national sort of a treasure here at NIAS Lab, where people can really think the technology and in all the areas, plus the important discovery that you guys make, can make a lot of important contribution down the road. Again, I want to thank all the distinguished speakers here. And I think before we go on lighting the candle, Professor Karup is going to say something, and I think then we'll hear from Dr. Kasturirangan, Dr. Balraman, and all the distinguished people here. We also have 3 people coming from United States. Dr. Hurley is here from FIU, and then Dr. Vijay Taingar from Duke University. You should listen to his lecture because there is a very beautiful story and the passion which he has developed. And the White House under Obama administration has implemented the mentoring scheme what he developed during his PhD study at Duke University. So there are a lot of speakers like that. So we will learn, and now I'm going to pass on to Professor Karup to sort of follow up this program. Thank you very much.
Thank you, Professor Iyengar. I'll just sort of take the next 7 minutes to broadly lay out the program and see how we are looking at the NIAS MAIYA Prodigy program at NIAS. NIAS has been engaged with research in understanding how do we identify gifted children in the age group of 3 to 15 years. We have been undertaking field-based research, and currently we have developed a protocol to identify gifted children through multiple methods involving both quantitative and qualitative tools. And hence it stands out than the usual methods through which children are identified. Currently, we have about 70 children in our pool. We have children as young as 4 years, and we have the oldest is about 20 years. We have been working with the Indian Institute of Science informally, where we are providing mentoring mechanisms for these children. And it is the NIAS MAIYA Iyengar Foundation program that we are right now launching has been a part of this extended collaboration where we are looking at the age group of 16 to 18 years. What I want to broadly say is, though we do not have a formal structure for the mentoring support that we envisage for children, I would want to say that NIAS is looking at a method of mentoring that would be at multiple levels, and you would interact with mentors more than one. So the whole issue is, the whole mentoring relationship is a symbiotic relationship that we want to develop, where the mentors and the mentees feel mutually convenient to work with each other at the pace and at a pattern that both of them would define for themselves. The review mechanism that we would put in place is after about 6 months to see what worked and what did not work, and perhaps over a period of 2 years, develop a broad framework, but definitely have flexibility within the framework so that the mentoring program that we are evolving here at NIAS would be able to cater to children from across the country, rural and urban, across the disciplines. Please treat NIAS as your home. We are here to help you. Use these 2 days to hear to a range of mentors who have experience across several fields, and also their experiences. You would make your presentation in terms of the direction that you have defined for yourself right now. And in the process, you would look for matching yourself with a mentor through a interactive session. So that is what we have laid out for the next 2 days. I would want each one of you to use this opportunity so that you would be able to interact and gain sufficiently through these 2 days. Thank you so much.
You will listen to Professor K. Kasturirangan soon. I strongly believe that a person who has achieved does not need biodata. To me, Mohandas Karamchand Gandhi or Rabindranath Tagore, we never know about their biodata. Dr. K. Kasturirangan is known to everyone for his contributions to space. As a young person, he pursued astrophysics, then made space science and technology, served Rajya Sabha, was a president of the Academy of Sciences in Bangalore, president of Indian National Academy of Engineering. He was a member in Rajya Sabha. He contributed immensely to the nation building as a member Science and Technology Planning Commission, so on and so forth. Whatever he has achieved by virtue of his commitment, his passion, his love for this country, and his continued aspiration to see this country to be among the finest country in the world. Because I don't believe in superpower, emerging, developing. I think you have to make a fine country. And today that is something very important. Dr. Kasturirangan stands for that. He's a wonderful human being. Please don't miss the opportunity to interact with him. And he even offered that any time you are here, you are in this nest, please come, and he'd be happy to spend. You are 2 or 3 or 5 or 10. Don't structure anything. So don't miss that opportunity. He'd be available. Thank you very much, Dr. Kasturirangan, for making it available.
Good morning, Dr. Baldev Raj, Dr. Iyengar, Dr. Ram Rao, Dr. Balram, Dr. Anita, mentors who are here, the faculty of the National Institute, and my dear gifted children, and ladies and gentlemen. I am indeed thrilled to be here this morning with all of you. When Dr. Baldev Raj wrote to me a few days back, I don't think you gave me much notice. He said that this is the kind of activity that NIAS has undertaken of identifying gifted children, and they are going to come here together for mentorship, and that he would like me to be present at the inaugural session. I thought it's a very innovative step of NIAS, and even though I knew that Anita Kurup has been working on this for some years, but that it was culminating in a very unique fashion of bringing the gifted children and the mentors together and make them interact, and thereby enhance the outlook and the way in which the gifted children should look at the world beyond their own, the present limited perception. So I thought it's a wonderful thing to happen. And also, I saw in the more recent details that Dr. Iyengar is involved in it. I know Dr. Iyengar for quite some time, and he was chairman of ISRO, and he was actually a visiting Satish Dhawan professor at the Indian Institute of Science. An extraordinary person, more than being academic, which he is. He has got very wide-ranging interest in the society, bringing up students, bringing up excellence in the area of anything that you try to do, excellence and perfection, for which space is one of the good examples. So I really like him because of that kind of a thing. He is not exclusively sitting inside his laboratory and pondering all through the day and writing some papers. He is more than that. He has done quite a lot of it. He has a very good standing in the academic sphere, but he is more than that. And of course, Professor Ramarao, a very key colleague of Professor Narasimhaiah, erstwhile Professor Narasimhaiah. I used to go to National College when Professor Narasimhaiah was alive, and he used to invite me for those national programs, annual science programs. A wonderful person. Actually, you should see him to believe. A Gandhi cap, a simple dhoti, and lying on the floor. That is the life. He has a PhD from Chicago on physics, and that is the life he led. He was a kind of a model for anybody. And then, of course, today I'm fortunate to have my old colleague, Professor Balram. We worked together for 10 years at the Indian Institute of Science and in many other fora. And of course, it's a delight to hear him. He is one of those intellectuals in this country whom everybody should hear at some occasion or other. But coming back to my friend, Dr. Baldev Raj, I know that he is really shaping this institute. In fact, Baldev, today NIAS looks very different in the variety of things that he has undertaken and created a vibrant ecosystem in this place for many activities, gifted children being one of that. And I know him, of course, again for a long time, and we worked together when I was in space and he was in atomic energy. In a sense, I could say that he was the father of the fast breeder reactor, one of the very key elements of a nuclear power for this country, likely to be operationalized in the next 1 or 2 years. But it's very important, and is one of the most important part of the three-phase nuclear cycle, fuel cycle that Baba has initiated. And he's the one who really is translating that. He had translated it. And also I remember when I was in trouble, the ISRO was in trouble with respect to the launching of one of the very powerful launch vehicles, the GSLV. And somehow it got aborted on the launch pad. There was some flames. The world interpreted that the vehicle has gone completely, out of control. But then we found out that it was only one of the aborting system that worked because of something malfunctioning of one of the stages. And we really had to find it out. And a 44-meter tall, 300, 400 tons in terms of takeoff weight, a huge structure, like we do a CAT scan or an X-ray on our body, we wanted to do that for that whole vehicle. And so I had to call my friend and ask him, what do we do here? Now we have to get to the bottom of what had happened. And he said, don't worry, I will try to get it. And he came with a set of people and did a whole neutron radio. It's an analog of X-rays or CAT scan or whatever it is, but he did a neutron radiography of the whole vehicle, the 44-meter tall vehicle. And then we located where exactly was the anomaly. And of course, in the next 20 days, we worked hard, really hard, because we wanted our first vehicle to be successful, first test vehicle. I would say, what is the significance of that? 4 countries had launched before a similar vehicles. Each of those countries failed in the very first attempt. When I became the chairman, we resolved in ISRO that we should have the first launch successful. Having 4 countries having already had failed and they have then succeeded, there is no reason for the 5th country to fail in the starting point. And no table was turned to make sure that nothing was wrong. And so this anomaly occurred on the ground, detected it thanks to Baldev and his colleagues, and then in 22 days we flew it as a successful mission. So that is the spirit which ISRO had, that we won't give it up. If things have happened in ISRO which are not very comfortable, but I think they were the learning, always a stepping stone, those failures, those anomalies as the stepping stones for the success. I just want to tell you this because all of you will meet in your life Today you are gifted children, you will be pampered and everything. Then you will enter the real life. And when you learn the real life, you need something more than what you immediately possess. And your own initiative, your innovation, your creativity, and your ability to think out of box, I think all has to be brought to bear in trying to make sure that you go over many of these kind of hurdles. So this is one example. We had to come together, many departments came together, many people come together, they work in a team and identify the problem, they launch it within a short time and get our name in the history as the country which launched the first launch vehicle, the geosynchronous vehicle, in the very first attempt, a successful one. So that's, I don't have to say much about NIAS. I think both Anita and Baldev had already mentioned about it. I should compliment Anita for systematically building up the education program of NIAS, and she has taken it to several dimensions covering policies, advocacies, education, pedagogy and things of that kind. So she is one of those persons who has given really her heart and soul into this area. Now coming here, I just wanted to know exactly what type of audience it will be, because they said gifted children, and you can't give on talking about highbrow science or highbrow technology to such a people. What is it that I should be speaking? So I had again a discussion with Dr. Anida about what I should be speaking on this occasion. And he said, you just share your experience in life. That's good enough. I don't think that we are expecting anything more from you for this particular audience. Before that, of course, I had gone through a lot of things on what Marconi did or what Faraday did, on what kind of chemistry was there, what the Carl Friedrich Gauss did in mathematics, or all those kind of things, just to see that how you yourself are getting very excited about reading many of these things, even though you do it occasionally only. But then, after doing all this, when I called Anita and said that this is what is it that I should be speaking, and she said that you just go through your life's journey. I thought that's okay, that's easier for me, but at the same time maybe a little more authentic. When I talk about Faraday and Marconi, certainly I am not authentic, I am quoting somebody else's assessment, but at least I can be sure that what I am. But that doesn't mean that I am going to speak about myself. Be very careful, and Baldev had already warned about it. What I am going to talk about is the incidents, the anecdotes, the excitements, the people behind it. They are the ones that who made this possible. So it is not necessarily that when I talk about my life's experience, it is my own, what I did or what I did not do. That is not the whole idea. Well, I had a school education in a town, Ernakulam, in southern part of Kerala. Those years, I am talking of 1940, very, very pristine, pure, the nature, and the nights were very beautiful because of the fact that there is no electromagnetic pollution compared to what you have in the modern lights. Excellent to look at the sky, look at the Milky Way, which I don't know how many times we can see really Milky Way nowadays in the nights, but such a beautiful necklace straddling the sky. And it really triggers a very interesting phenomenon in your mind. So that is a kind of a thing. Really, it injected a kind of a excitement, a wonderment as to what is all this about. And that's the way in which I got into my interest in astronomy. And somebody told me that if you have to really understand astronomy, you have to also understand physics and mathematics. You can avoid physics and mathematics in life now. I can tell you one thing, that any subject, whether you take agriculture or whether you take economics or whether you take gambling, you can be just assured that physics and mathematics, of course that includes statistics, is a must. So that is where I was told about this at that period in the 40s. So I decided that I would pursue the area through physics and mathematics, and ultimately with the idea of going to this. So I had my school education, my college education, all around this kind of an objective and this kind of an attitude. The only thing I remember and recall and worth mentioning it to you is that, we had a lot of time those years as school children. You have a three-month vacation, and then every time an examination is over, you have a great relief. A Saturday will be the normal day, and with the examination half day it will be over. I was studying in the Matunga school in Bombay. It's a South Indian Education Society, so school, very interesting teachers, an excellent environment. But then what fascinated me in some of these old cities, and this happens not only in Bombay, that in the footpath, plenty of old books are kept and they are being sold. Even if you go to London now, I think there are footpath books which are available. So my interest was to go to those footpath bookstores. They are not bookstores, they're just laid out on the footpath, and people give respect to this, so they don't insist that they should take it out. And all you have to do is eat any book. It may be a fantastic book, it may be a story, it may be a history, it may be books on legends and myths, it may be on adventures, many of these. And you have got a variety of books. And then you have got classics like Victor Hugo and Alexander Dumas. And what an English and what a description. A whole chapter will be on a landscape description. That is the kind of a thing. You had that leisure to go through this. You had that interest to go through, and you paint yourself of far-off lands and their culture and their life. So you don't travel because there are not many planes available. You can't do all that. But those books took me to far-off lands, and especially if you read something like The Lost World of Conan Doyle and look at the pterodactyl flying out and all kinds of prehistoric animals. These were the kind of things that happen. So this is what ultimately triggered me into the process of learning, process of trying to understand, and the process also you get an insight. So then came my college education, and after that, of course, the college education had a similar thing. Then my interest was in the question of getting a PhD, and I was a research bent of mine, and I also knew that if I had to do really astronomy and understand many things that are going on in astronomy, you need to really do some research. And I was looking for an opportunity, and that is the time at which I got an opportunity to meet Dr. Vikram Sarabhai at the Physical Research Laboratory. He was a wonderful person. I should say Dr. Vikram Sarabhai he was a visionary. He was at that time thinking of how to, 1957 was the launching of the Sputnik, actually October 4th. And in the next 2-3 years, he was in India, and he started thinking, how do we bring this concept of a new vantage point of space to this country, and found what its usefulness is. He went through several consultations, both within India and outside. He had contacts all over the world. And in the process, he tried to get an idea of what is good for this country. And he had been coming out with a blueprint. This was in 1962-63 kind of a time, just 3-4 years within that launch of the Sputnik and the American Vanguard. And he was creating laboratories, recruiting specialists. In fact, if I recall, people like Dr. Abdul Kalam, Dr. Gowarikar, Dr. U.R. Rao, they were all the first set of people who came and got recruited into this program. And we were some of the students. We got an opportunity to work at this particular time, 1963. I went and met Sarabhai. Initially, of course, he tried to dissuade me from doing research, simply just to test how serious I am with respect to doing research. But I explained to him all the things of what I want to do. Not that at that age you can explain so beautifully and convincingly about what you want to do with research, but nevertheless, for at that level of my understanding, he still appreciated this and gave me a fellowship. Worked for the next few years. But the most important thing he told me was that you have to work in experimental physics. I don't want you only use paper and pencil and do theoretical physics. And there are a lot of people who should be needed in this country who understands experiment, how to do experiment, how to think about creating an experimental setup and things of that kind. So he said that this is what I would like you to do. And then he gave me a job to develop an instrument. That instrument was to be detecting radiations from outer space, and therefore there are what is called the Jaeger-Muller-Kaula. I don't want to go into the details of that. Then you have a pulse processing electronics, digital electronics, RF electronics, transmission, reception, demodulation, then recording. So, you know, the beautiful way you have a whole system, right from a sensor right down to detection and recording and things of that kind. And so you try to get a feel of the total system. And his whole idea was that if you learn this kind of a thing, you become a kind of a systemic approach in understanding things. And if you understand this systemic approach, you are not a mechanical engineer or an electrical engineer or a thermal engineer or a control engineer. You are something more than that. You understand the relation. And the time when I came to know why he was doing this is not only for getting my PhD, which I ultimately did, and which I did in which I looking at the areas like cosmic X-rays, the deep radiations that were coming out of the primordial radiation, in which ultimately it became the universe, which was extremely hot at the time of the Big Bang, finally cooled down and is presently something like 2.7 degrees Kelvin. And this cooling process reduced the universe to a large number of photons at this energy, a few electron volts. And when you have also processes which are reduced to high energy electrons, there is a process called, you know, Compton effect. The analog is the Raman effect in the optical, and inverse Compton effect, where a high energy electron lifts the photon to a higher energy and makes it into X-rays, lower photons, radio photons to X-rays. This is the kind of a process which you call it an inverse Compton radiation. Those X-rays could be pervading the universe. It could be a background. It would be interesting to know what that X-rays are, and from that deduce things about what could have happened in the early part of the universe. So that was the interest of the problem. I did this and got my PhD in this, and in the whole process, learned also the systemic engineering of doing things. And at that time, I was looking for a position. As usual, all PRL people try to go abroad as a postdoctoral. And so I addressed this to different places. I got a fellowship with Professor Luis Alvarez, who was a Nobel Prize at Berkeley. He worked in areas of bubble chamber and so on. He was wanted to build a high energy astronomy observatory in space. And my experience and my background, he said that I could have you. So I was just waiting for the final funding to come to him. It was about 2 months away. But then in the meanwhile, I saw Professor Sarabhai, and he said, what are you going to do now that you're doing your PhD? I said, this is what my plan is. He said, no, I don't think that was the whole thing, that my idea of you doing PhD here. And then he took me to his room, and I said that, I wanted to work in India's space program, you know, satellites and rockets and kind of. I was aghast. I was wondering, what is this? You have learned physics, you have done some experiments, you have done some learning of instrumentation and other things. He said, how do you build a satellite? Satellite for us was a very mysterious object, something which contains so many types of electronics, so many engineering, structure, thermal, power, control systems, electromagnetics, integration, and things of that kind are fairly intricate in terms of multiplicity of these engineering and technological disciplines coming together to finally get a product called a satellite. And I didn't know what justice can I do for that kind of a thing, having learned this kind of a thing. He sat with me, explained, you know, he was the leader in this country, but he had no compunction to sit and spend 1 hour with a younger fellow, just because he wanted to convince him that I have a wrong idea, his ideas are the ones that I should think about. And he explained to me why structure and physics are related, vibration theory, thermal and physics are related, Planck's law and Stephen-Boltzmann law, went into the communication system, the sampling theorems, he explained electro-optical systems, he said about diffraction, reflection. See, in each one of the satellite technology, he told me what is the physics content in it. So between 15-20 minutes, he explained to me what the physics content in the technology of a satellite is, and how people like Fred Singer in Maryland or John Simpson in Chicago, they build spacecraft, they are the first-rate physicists in the United States, and they build the spacecrafts. So that really bowled me out. There was no way I could contest with him and say that my experience is not relevant to the type of position that he was looking for. And he said, you will be one of those few people who have a systemic knowledge. I'm going to have a lot of engineers in structure, mechanical and electrical, but a person who understands the systemic aspect of this, an aspect which gives you the totality of the picture, I think there will be few people like you, and that is exactly where I am going to put you. And thus he persuaded me, he made me stay back. And then I think there was no looking back. He never given an opportunity to even think of going abroad, because the excitement, then we started in Bangalore, we built satellites, and you know, at that time U.R. Rao came back from US, and U.R. Rao, he put him in charge of the satellite program after having been at MIT and Texas, and we worked together in setting up the place here, the satellite center, and things of that kind. The life went through. It was a very interesting life. The first satellite, IRS, that's the only thing I can say. The first of the satellite, the Aryabhat, which was done with the Soviet, at that time Soviet Union, we worked together, and the first satellite was built in 40 months. You know, there was an urgency that this satellite had to be built. It has to be Indo-Soviet collaboration. There was a Brezhnev on one side, there was Indira Gandhi on the other side, and they were politically decided that India should have a very good satellite and space program. So once that is decided at that level, there is not much we can do, so we started working on this. I think we had to set up a laboratory, we had to find out all the institutions that were a part of it, and it just went on. So the next 30, 40 months, we built this satellite, we launched it with a Russian vehicle, Soviet vehicle, an intercosmos vehicle. It was a nice experience to see the whole satellite working in space, a very first thing. But what is interesting is you have wetted your hands on the ground, it was working there, you know, you are getting the signals, you are looking at what is happening to the satellite. This was the other part. That's how the whole thing went. And then, of course, we built a satellite using this kind of a configuration to look at the images from the space. taking images from the space, then you look at the ground, you look at various types of features, you understand what is the water, what is the agriculture, what is the vegetation, what is the geology, what is the oceanography. So the various types of resources, natural resources, you try to fix it up. So this is another area. So we worked in the second satellite, which is called the Bhaskara, where we built this. The only point I would like to say, by that time Dr. Satish Dhawan had taken over Sarabhai, an untimely death, left this world, and it came on Professor Satish Dhawan, about whom unlike Sarabhai, who was a visionary, who was an industrialist, who had a pragmatism, and who had also a very broad and grand vision about India, Satish Dhawan was very focused. He was an academic, and he, of course, as Professor Iyengar mentioned, he was a student of Professor von Lippmann, who himself was a student of Theodor von Karman, and Theodor von Karman, as you know, was the father of American astronautics. So he had a very focus, and he was an institute director at the time when he was called upon by Indira Gandhi to take over the charge of space after Sarabhai passed away. He was very, very focused, and one of the episodes I would like to say is this first of the Aryabhat Bhaskara satellite. It's a television camera system taking photographs from space. It has a high voltage system. The high voltage, sometimes under some gaseous conditions, very low pressure conditions, you can get into discharge mode. Discharge can create electromagnetic interference, and electromagnetic interference in turn can create problems of the whole system getting disturbed. So this whole thing had to be understood. So this, suddenly it happened for our first satellite. And then we had to go to Professor Dhawan and asked him, what is this problem? This problem is coming, we need to look at it. He said, I don't think you're going to retrieve it back, but if you can, it will be great. So one of the youngsters and a few of them, they said they will go into the simulation of this problem, understanding the problem, look at it by putting it in a simulation chamber, do mathematical analysis and other kinds of models that we wanted to do, and ultimately thought that we understood exactly what was happening, and there is a good likelihood that the discharge of the gas from the occluded region, where the gas was occluded, could stop the radiation or discharge. And once the discharge stops, then it becomes a hard vacuum, and in hard vacuum there is no gas for you to discharge, and therefore the problem can stop. So this could take about 5 to 6 months. So that is all you can do, because it is sitting on the space and you cannot do anything sitting on the ground. So then at that time it was found that after 6 months we decided to switch it on. And lo and behold, the spacecraft returned the first imageries, the first satellite from India, taking the first imageries of India, taking from space, and it was there on you to see. That was the greatest thing. So, what I want to tell you is, here was a leader who could appreciate this, but who wanted to thrust us and challenge us to get out of the problem. And here was a system which is not easy to access because it is in space. And you need to go through a systematic way in which to understand the problem. And then we retrieved the situation from what was a lost case through the intelligence, originality, and the knowledge that these youngsters possessed. Most of you are people like you, people who have just come out of IITs and other places. They played that role. And Satish Dhawan was behind us all the time to make sure that we do this. So this is just one example of that. And there are, of course, Satish Dhawan's case, of course, he is a man of perfection. In fact, Dr. Iyengar mentioned about this. One of the important things that he always wanted to make sure is that when I go with a solution, or when he says you study this issue, maybe it could be related to the orbit of a satellite, and you say which is the optimum orbit for the satellite, you work out and tell that 900 kilometers, this is the altitude, and the atmospheric drag is less, and there's the right resolution for your camera, all those kind of a thing, you put it down and give it to him. He said this is the only orbit he will ask. And then he will say that why not 700, why not 600, and why not this inclination, why not the other periodicity. So every parameter of the orbit, he will question you why not the other options available. He made you work with 6 to several options. So ultimately, when you work on 6 or 7 options, then ask you, tell me for the first option, second option, third option, which are the pros and cons. Here money will be more, technology will be complicated, maybe time will be less, or of parameters you try to see for each one of them. Then you give a summary of the whole thing. Then looking at this, now tell me, if I am giving you this table, which is the one that you will choose? He will never choose. Then you look at it and say, this looks appropriate, sir. He says, yeah. So you come to this conclusion? So the earlier conclusion that you came to me was a different one. Now you are coming with another conclusion. But this is the optimal solution for the problem. I'm happy that you came out to this, and then he will make you select that particular thing. But you know, it taught you something very interesting in life. Never take anything in the face value. You just need to know how to take it rightly, how to analyze this. You yourself should get into the details of that and look at alternate options and take a very considered decision. These are becomes a wrong decision in this kind of a thing can be very costly in life in the later part when you go into the professional thing. And that's what Davan really taught us, how to take decisions in a complex environment. It is related to technology, it is related to budget, it is related to time schedules and many other considerations that is there. And after all these things, of course, your Rao took over, he pushed the satellite programs and other things. He was also a very dynamic person. He really, if you ask me, anything that he wanted to do today, he wanted to do it yesterday. So it really kept all of us on toes. And I don't want to say, he also understood. See, one of the important things you should remember is you have to be a good leader, especially in places like ISRO. I found this. You have to be as thorough as others in terms of technologies and other issues. You cannot be a leader by being just a manager. You do this without understanding the totality of it. This is something which is extremely important. Anything you have a responsibility, try to get into the details as much as you can. This is a tremendously demanding responsibility that you will have, but something which you cannot avoid. And that's exactly what we were all taught. And URL was extremely good in pinpointing things. So he can really beat an engineer when he makes a presentation. He would have worked for weeks. And he just saw it only 10 seconds back. But he can point out a thing there which they have overlooked. So that is the kind of the ability that you should have. We all learned out of that. And so that's the region. And then you have developed many of those rockets. PSLV was come to the final stages. He had already started working on the geosynchronous launch vehicle and things. I don't want to go into the details of that. And that is around the time in which I was asked to take over the space. And I had a space program which had to be consolidated. There were a lot of things. So, but worked on many things. PSLV was operational. And today, PSLV is a workhorse. The Polar Satellite Launch Vehicle for India is a pride of a vehicle. Is a great workhorse. GSLV has to be pushed. So there is another major thing. And also initiate a new program on the Mark III version, the upper version of the GSLV. You know, all these, when you talk of this kind of a thing, I'm not going to go into the technologies of it, but I want to tell you one thing. You have, as I said, these are all multidisciplinary areas. So you've got a variety. When you talk of a launch vehicle, you talk of a structure, you need of aerodynamics, and the propulsion systems, control guidance and navigation, and things of that kind, the thermal systems, the heat, separation dynamics, and things of, and propellants. So there is a whole host of technology. They have to be designed separately, brought together. Synergy has to be there. A configuration has to be defined. And then ultimately, of course, the simulation has to be carried out. Modeling has to be done. And where possible, the testing has to be carried out. So this is a fairly elaborate, and typically a launch vehicle takes between 7 to 8 hours, 8 years, even in an advanced country to develop. So that is the kind of a thing that we were working on, and thousands of people will be working, thousands of engineers, but they cannot have one wrong communication between the two because that will be suicidal for the vehicle. So you should really see that kind of a thing. So that's how these developments went through. The PSLV was successfully operationalized, the GSLV was successfully tested, the initiation of the advanced GSLV, and I want to say this advanced GSLV Mark III, I think next month we will have the first test flight of that. That's a very, very big thing. It can put something like 4 to 5 tons into the orbit, geosynchronous orbit, which will be one of the biggest vehicles in the world. And that's where we will be. And with all these kind of a thing, of course, there was this satellite program to even strengthen with represent application. How do you use remote sensing satellite for a variety of applications? I mentioned about agriculture, vegetation, forest cover, and things of that kind. And also at that time, we thought about a satellite called EduSat. We wanted to see whether there can be a satellite specifically for education. Education is an important area. And whether there is something unique about education that can be catered to by a satellite configuration. We worked on it. We launched a satellite. I think it has not been carried forward, even though we had some reviews on that particular thing. But it's an idea worth revisiting. But I want to talk about one specific area which is related to two important missions which we initiated. The first is to go for a planetary mission. And it's not easy to sell an idea of that kind because people will ask, "Isme kya matlab hai? We don't have water to drink and we are talking of planetary mission." So they will ask this question. And similarly, an astrosat mission to look at the skies. You can look at the sky, but before you look at the earth and find out what exactly is we have to do for surviving. These are the questions that will be often asked. So how are we going to answer these questions? So we did an exercise for 4 years in planetary mission. We started with a small lecture among the glitterati of Delhi and tell them importance of how India's present PSLV capability or a satellite capability can put a satellite around a spacecraft around the moon. It can go to Mars, it can go to Venus, it can go to Mercury, and even it can go with a limited weight even to Jupiter. So this was told to them. There was a lot of interest because the attendance was people from policy making, the intelligentsia of Delhi, the parliamentarians, minister. It was chaired by Murali Manohar Joshi at that particular time on this program 2 day celebration, and there were of course a lot of media people. So 400-500 people in the hotel coming together to hear about India's space program. And when I enunciated this question of a planetary mission, I think it caught the imagination. Next day, India eyeing for moon was the title that they got. And but then that is not good enough because you have to justify to the nation. So we went through a process of 4 years of looking through this and consulted several areas. Academies were consulted, academicians were consulted, policy makers were consulted, even presented to the Parliamentary Standing Committee on Science and Technology what this should be. But everywhere we got a substantial support for this kind of an idea that India could go for a planetary mission. And so finally we sent a letter to Vajpayee, who was our Prime Minister at that time, and Vajpayee looked at this and he said, it looks very interesting, but whom have you consulted? And because he was also worried whether the country will react to it in a bad way. And then we said that we have gone through 4 years of assessment and there is a general positive response from this. Then he said, then what shall I do? Sir, you are the boss of space program in this country. Why don't you make this announcement in the forthcoming Independence Day, your address at the Independence Day address from the Red Fort? He said, good idea. Why don't you give me a note? So we sent a note to him. The note contained 2 important things, that we will go for planetary mission. Chandrayaan will be, the name will be called as Somayan. We give the name Somayan and we just send it to him. Next day, when he made the announcement at from the ramparts of Red Fort, he said that India is going to go into a planetary mission program. India's mission will be Chandrayaan, it will be called. The mission will be Chandrayaan 1, and we have to take a decision of the government to go ahead with it. I think the nation received it very well. But what did puzzle me is, he had changed it from Somayan to Chandrayaan, the name of the satellite. He also, spacecraft. And he also had put 1 there instead of just leaving it like that. So when I met him again next time and I said, sir, you have made those changes. He said, yes, I consulted some Sanskrit specialists and they felt that Chandrayaan would be a better word than Somayan. And 1 I put because how can India do only 1 planetary mission? It should be a series of planetary missions. So I am calling this as the first of those planetary missions. What a vision a politician had. So, you know, the sum total of major decisions in this country doesn't come from scientists. We should never have this illusion that the scientists who can't dictate the country's requirement. They have a better perception of what is good and what is not for the country. If you can plan your system having understood that kind of a character of the system, the political system, it does help you because you will not go across with them, and you should also make sure they make those announcements. Big announcements are never made at the scientist level. They are always made. So these are the kind of thing I would like you to do. There are many things that happened. The going for Mars was a very big exercise. India did it in the very first attempt. The only point I would like to say is, I talked about precision, accuracy, and perfection. If you really look at the Mars, you've got to travel something like 300 days. And your time of communication is about 22 minutes to and fro. If you say hello from here, it will take 22 minutes for the guy there to reach you a message, hello. So that is the kind of a time that you need. So you can't make on-night corrections and things like that. So you need to make sure you have onboard intelligence, you have got expert systems so that they can completely correct the things, anything that go wrong. So you have to envisage all those things. You have to build such kind of checks and balances in the system. So this was one aspect of it. And if you make, such a far, more than 400 and 500 million miles, that if you make a mistake in certain directions in which you have to fire this, I can give you one example. If you, the kind of accuracy that you need in shooting it to the Mars, the Earth will be here, moon is here, sun is here, Mars is here. By the time 300 days are over, you can compute and find out where will be Earth, where is the moon, and so it has to maneuver the trajectory to go to the Mars in a fairly complicated fashion through the interplanetary space. And if you make a mistake in terms of this, I just want to say there is a 20-kilometer dispersion when it is about to leave the Earth. If I make a 20-kilometer dispersion, then if I make a mistake beyond it, it is like an accuracy that I need. I put a coin, a 1 centimeter coin at a distance of 200 kilometers, what I may call it a 1 centimeter diameter coin, keep it 200 kilometers from my rifle, and I fire this, and I have to hit it. That is the type of accuracy that you need. So you can imagine the kind of precision and accuracy that you need in the control, guidance and navigation system if you have to do. So these are tremendous challenges, and these are the first step of challenges. By the time you people grow up, you are not, I saw some of your aspirations in your notes. Some of you do want to become space scientists. I think your aspirations would be such that this will look like a babe in the wood compared to what is expected out of you. But that's a great challenge that many of you will try to go. Well, after all this great excitement, I stepped down. One day I was told that now I could get out of the organization. Vajpayee put me as a member of the Rajya Sabha, a very different kind of an environment. I had my own reservation whether I should get into Rajya Sabha or not. But then he was very convinced that a person like you can have certainly contribute not only on science, but the broader aspects of the country. It's a very different kind of a forum, you have to be very careful. I can easily talk to all of you for 1 hour or 2 hours or 3 hours, but to make some 10 minutes of sensible thing to Rajya Sabha members, I think you have to sweat it out. They are terrific fellows because they know precisely what the country needs. You know what your subject needs. They know what the country needs and what the international community will look at it. And this, I should know, you have to experience this. I cannot explain the complexity of this. So every time I spoke for 10 minutes, you have to really work on it the previous night, consult several people. You have to be little one upon them. Otherwise, you are not anybody. And this really came to the surface when I was asked to also participate in the nuclear deal, the question of India signing the nuclear deal. And here they knew that I had a little upper edge over many of the other parties. So the Congress came and told me that you should speak on it. The BJP was trying to oppose it, all those kind of a thing. But I didn't want to take any sides. I went and told the BJP guys that I'm going to support Congress, not because I'm supporting Congress, but because the program is important and I have to support it. I told the Congress, certainly I can do, but in 7 minutes I cannot do. They said, you take all our time. As a nominated member, I can take only 7 minutes. So they said that because an important area and you're going to support the bill, but you please take as much time. I spoke for 30 minutes and gave a lot of interesting points which were not coming out in the other kind of discussion because it had scientific and other strategic issues. And ultimately, I think my presentation was received well. The best certificate that I may say is that late in the night, Manmohan Singh was the Prime Minister, called me and said that your lecture was really very good and I understood several issues which I myself was worried about. So I think I could not have got anything better. So, but then you need to work, you need to understand issues, you need to make sure that what will the other guy respond to. Even while saying this, Arun Shourie had one thing say, I do agree with the sagely advice of Dr. Kasturi Rangan. That is how he started his lecture after my talk. So you can see, the politicians are politicians, nothing you can do. But then this is the kind of an experience. Later on, I was moved over to the Planning Commission as a member of the Science and Technology, Forestry, Environment, Agriculture, Research and so on and so forth. I think a good opportunity to look at the planning of the country, and I think you learned a lot. Again and again, as you go towards one level to another level, you thought you were great as an ISRO man. It is not. You were told how little you are when you went to the Rajya Sabha. Then you go to the Planning Commission, you see how minuscule your knowledge is compared to the total system that this country is and the type of planning that you need. And these are the excellent ways in which you try to get exposed. Not that everybody gets this, but when you get it, you have to realize that this is the kind of a thing. I did that. And of course, even though the 12th plan was formulated, there are major programs which you should be interested in. Somebody may talk about it, maybe Balram, on the mega projects that the country is undertaking as an international collaboration, whether it is in the Higgs boson discovery in the CERN, or whether it is related to developing the ITER, the nuclear fusion reactor, as an international collaboration, or the 30-meter telescope that is going to come up at Caltech, one of the largest optical telescopes, or square kilometer array, which is a radio telescope that is going to come up. So there are, and India itself is trying to now struggling it. I should say struggle with the nuclear, the neutrino observatory that we would like to put in this country. So there are several opportunities of fantastic nature, something which we could never dream of. This is what this the future of India is, and India is a part of this. And most recently, the Prime Minister also decided that India should be a part of the LIGO, the laser-based interferometer for gravitational wave detection. You know, it has been detected, it has been validated, and it's going to be a Nobel Prize-winning discovery. And the third node for this particular LIGO is going to be in India, and there is a decision at the highest level. So these were the kind of things that happened. Left Planning Commission, then decided to quit the public service, came over here. Thanks to Baldev, I became a Satish Dhawan Chair Professor, decided to write a book on some of the key elements of India's technology requirements, and now working on it. I have already slipped considerably, but then that is how the life is. Slipping was never allowed in space, but I think now I am having the luxury. That is all I can say. And then I will complete it, and then there are many other things that are happening. I keep giving lectures and things of that kind. And but I want to conclude by telling it was a great journey. Not so much because I was great. I think the journey was great because the people, the ecosystem, and the opportunities that were there were great. All that you do, you played your little role on that. But I think that is what this country presents today. This country is no longer what it used to be 30 or 40 years. Anything you talk of in this world, I think India can have a role in it. And so one thing is, all of you guys, you really don't have to worry what is going on in Stanford and MIT, which is extremely important because there many things will happen. But what is going on here is going to be equally important. After all, 1.2 billion people and their problems, addressing them and making solutions to them, whether it is in education, whether it is in health, and many other kind of a thing, I think it's a must that most of the best of the brains are there. The 10 of you, the Magnificent 10, I wonder call there the Magnificent 7 movie. This is a Magnificent 10, which I read your little bit of interest. Many of you want to become doctors. Some of you want to become a mechanical. You want to become even specifically, you want to become a mechanical engineer. Some of you said you want to become a space scientist. You want to become life sciences person. So there is a very broad picture which you are given about your interest and all that. I think these are exceptional areas. I think each one of them you can make it a great success. There are also the liberal arts. I don't want to totally overlook that aspect of it. I think at the end of 4 years from now, when you try to graduate, complete your undergraduate education, I think your mind should be able to exercise independently and with a critical judgment of issues. If that capability you get at the end of 4 years, that's the biggest asset that you will live out with the education that will provide you. This institution certainly is a right place. The people like Baldev Raj, Dr. Anita, and supported by Professor Iyengar and Ramarao. I think it's an extraordinary institution. I am sure that you will find the type of worries that you'll find solutions, or you'll try to find how to approach those problems. I think you will find that kind of a thing here. But I won't like to conclude this, but by remembering something which is the general ambience that NIAS represents, which I would like to say, the general ambience of this wonderful meeting itself that NIAS, along with other institutions, have organized. But I cannot but resist concluding this address by the following observations from Albert Einstein, and I want to quote this. He has said this in the context of some students somewhere. When I picked it up, I felt that it's as much applicable here, because he uses the Phoenician words, "My dear children, I rejoice to see you before me today, happy youth of a sunny and fortunate land." I think which can be better than the sunny and fortunate land that's the country. Bear in mind that the wonderful things that you learn in your school are the work of many generations, produced by enthusiastic efforts and infinite labor in every country of the world. All this is put in your hands as your inheritance, in order that you may receive it, honor it, add to it, and one day faithfully hand it over to your children. Thus do we mortals achieve immortality in the permanent things which we create in common. If you always keep this in mind, you will find a meaning in life and work and acquire the right attitude towards other nations and ages. Thank you.
Friends, if you would like to ask anything from Dr. Kasturi Rangan, floor is yours.
You had said that you got inspired by the night sky when you were growing up, but the night sky is no longer clear, which I can say is a euphemism for saying that inspiration is a little hard to come by now. And, huh?
She says the night sky is no longer
Yeah,
clear.
that I understand.
Yeah, the inspiration is a little bit harder to come by now because, I mean, we have lesser time and more competition. So, your advice to any people who want to pursue pure sciences and to keep being inspired throughout that, do you have any advice for us?
I think there are certainly external forces that can really inspire you, the environment, the ecosystem, and things of that kind. But I think something fundamental about the science, and I mentioned about this, is it is one of the areas where the inspirational aspect is natural to the human curiosity and human exploratory tendencies. And this part of it is resident, implicit in every mind that is there. The question is, how do you try to take it out and then manifest itself? I said in the end of my talk about, unfortunately I didn't mention it because it was there, that quotation, that the best way to get into the scientific spirit is the one in which you keep your mind out of goals and strong achievements. You need to keep your mind away from influences which will direct you in one direction or other. If I have to build a satellite, my mind is only on satellite. My creativity is only on satellite. I want these 4 years of yours to be spent without unnecessarily being too much influenced by the end goals. The ability at the end of the 4 years will be such that you can independently think, apply your mind to anything, any problem, and bring the best in terms of your ability of thinking intelligence to do that. So I personally, in terms of inspiring, I can talk of several instruments. I told about the mega projects in which this is there. You look at the universe, you want to, today there are many, many instruments that are probably, in my years, looking at the sky was the initial part of it. Today you can straight walk into a telescope and look at everything more than what I could see in the sky. So that is not going to be the problem to be overcome. What is more important is, are you in a position to independently think without having any inhibition with respect to what you have to ultimately get. That goal should not get fixed early in life. That is the only point, because it is too broad a suggestion. I can get hours of lectures on how to inspire you with many examples. That is not the idea here. Your independence of your mind, independence of your thinking, and it's also independent for our democracy, I can tell you.
Anyone more, please? Yes, please.
You had said about EduSat. Is that currently in our orbit, or is it yet to be launched?
I think it is not operational probably, hopefully, I think so. The reason is, I think they have tried to transfer these to different satellites as a capacity within these are transponders. And these transponders enable you to receive the signal, amplify the signal, translate the frequency and take it down. That's what it does. Now this is available in many satellites, so they have tried to do. What is unique about EduSat, which has been overlooked, is it had a very high power transponders. You can create very small aperture terminals on the ground within minutes. So if I want to immediately look at my lecture in some adjacent university, I simply want to 10 minutes, they can put it up together, point that system to EduSat, and you will get this if you transmit from here. And these are all ground instruments which are simple, space instruments which are a little more complex. The whole concept in the generic term, the EduSat was supposed to achieve, was to create slowly more complexity on space. The present increasingly capable machine intelligence, artificial intelligence, expert system, can we integrate that into a satellite bus and make use of it in terms of quizzing, query shells, and many other kinds of functions that somebody, so that even with your mobile ultimately, you should be able to set the lesson that you want, which may be resident as a resource anywhere in this country or anywhere in the world. That should be the ultimate goal of an EduSat kind of a concept. So whether we go for that or not, I'm not very clear, but the present system is the very first rudimentary first step in trying to achieve that kind of a long-term goal.
Yeah, I thought maybe a satellite like EduSat could possibly use for teaching subjects like geography in a more practical way, like by connecting it to current weather pattern and stuff like that.
Yes, I'm not talking about the pedagogy or the material that is, anything that you innovatively think of can be done with that. After what it is going to do? It is going to do only the forward-backward connectivity. Second thing, it will also create some intelligence which can be used to locate it. For example, when you talk of a meteorology or you want to look at the weather system, I will make sure that there is an onboard system by which it can quiz the meteorological data of the IMD and then give you some of the latest information on whatever you want. So those kind of capabilities can be built into those.
We can all go for tea and you can continue to interact with Dr. K. Kasturirangan. Thank you.
Thank you.
Kasturirangan. It was wonderful.